Hello guys, welcome back to Calculus Universalis. In this video, we're exploring the power of the second derivative to analyze graphs, including concavity, points of inflection, and using the second derivative test to identify local maxima and minima. We'll break down what the second derivative tells you, how to find inflection points, and then we'll walk through 3 classic examples together. Let's get started. So what is the second derivative, and why do we care? The first derivative, f of x, tells us where a function is increasing or decreasing. So we have our derivative, f of x, f prime of x, is going to tell us where a function is increasing or decreasing. Second derivative tells us where a function is concave up or concave down. How do we do this? So some concavity rules are, if f prime prime of x is positive, concave up. And then the opposite, if it's negative, it is concave down. What does this mean? This is concave down, and this is concave up, down, where the concave is pointing. And then a point of inflection is where it changes from concave down to concave up. So it's going to be right here. It's like the midway point. You have a concave down parabola, concave up parabola. It's right where they switch. So it's literally going to go like this. The slope's increasing, and then it starts to slowly get less steep and less steep and less steep. So it's getting more steep, and then boom, less steep as time goes on. So those are some basic concavity rules. Okay. So let's try this out with an example. We have f equals x to the fourth minus 4x squared. Our first derivative is 4x cubed minus 8x. Second derivative, 12x squared minus 8. So we set f of x equal to 0, f prime of x equals 0, sorry. And then, this allows us to find our inflection points. So we set this equal to 0, we get plus or minus square root of 2 over 3. And we test these intervals around, and we find that from the f of when x equals 0, there is a concavity downward. So we have set up our little line test. Negative 2 over 3 square root, positive 2 over 3 square root. Plug in 0, a 1, a negative 1. And then this allows us to find that this is concave up, positive, down, and positive, which tells us our concavity, and our points of inflection are here and here. Concavities elsewhere. Alright, example number 2. We have f of x equals x cubed minus 3x squared plus 1. And then we're going to find the second derivative, which is going to be 3x squared minus 6x. Set this equal to 0, and we get x equals 0, and 2 is our solutions. Now what do we do with these? Make another chart, 0, 2, plug in like a 1, a 3, negative 1. And then with this, we find our concavity. Go ahead and pause the video to figure this out. So we find that this is negative, positive, and then we find that there is a local minimum at 2. So this is also positive. And then find that there's a local minimum at 2, max is 0. That's easy. Now for our last example, problem number 3, we're going to have, given the graph of f of x, determine the concavity for f of x. So if f prime prime of x is greater than 0, concave up, up. If is less than 0, down. And wherever it crosses x-axis, potential inflection points. So we need to look at where f prime prime of x changes sign. So if we have something like this, it changes from concave down to concave up right at this point. Let's say x equals 1. So that's our point of inflection. Anyways, to summarize this video and what you guys have learned today, you'll need to remember f prime prime of x tells you concavity. If it's greater than 0, concave up. Less than 0, concave down. Points of inflection happen when f prime prime changes sign. Second derivative test will confirm when f prime equals 0, and you can try things on your own. For example, find the point of inflection for x to the 5th minus 5x cubed equals f. You can also use the second derivative test to classify extrema, like x cubed minus 6x squared plus 9x. Given a graph of f prime prime x, describe the shape of f of x. So these are 3 things you can try today. Next video we're going to learn how to sketch full graphs using f prime and f prime prime together. Super helpful for both FRQs and MCQs. Don't forget to like and subscribe. I'll see you in the next one. Goodbye.